and welcome back again. So we are going today in our Linux cybersecurity coursework have a lesson on the concept of namespaces. We already took a little bit of a look to a lot of the facilities provided by Linux to protect the operating system and the running application. Potentially here we are getting in one of the most complex internal facility of the Linux kernel. So this is going to be our lesson 5, and we're going to talk about the concept of namespaces, which is not obvious at the first time. The various types of namespaces which are available inside Linux, knowing that this number keeps growing. We'll talk a little bit about the how-to and how to look at it and how to use them and what are the limitations. In a nutshell, NameSpaces will allow you to run tasks on a dedicated domain with the same performance as a native OS. Or if you want to summarize how to share in a homemade isolation, you decide what you're going to isolate and you only do what you have to do. Now, the concept of namespaces in one way is new. Very little people have heard about it until quite recently with the arrival of containers. And even with that, a lot of people still believe that containers is a type of virtualization, which in one way it is. But actually the concept is pretty old. It started with a project called Plan 9 at AT&T Lab in the mid-80s. And actually had a commercial launch in 1995 for the fantastic cost of $350 for the source license. And it was targeting embedded and small systems. Already people had realized that on embedded systems, which by definition are small, or at least were small at the time, we could not run what we were running on big one, and so if you wanted to do some isolation, you had to think in a slightly different way. For information, this Plan 9 operating system progressed smoothly, and few products were launched around it, but without really making it virtualization did take over, and in the year 2000, virtualization became big. But nevertheless, the concept landed on Solaris. Solaris was the operating system and still running on Sun hardware, which is now owned by Oracle. And the commercial launch was circa 2000. I could not find exactly the date, but I did a project for British Telecom using zones heavily in 2002. And the target this time was actually the web server. Year 2000 is when internet really started to blow up, which actually created the internet bubble, which did burst actually after that. A lot of companies went bankrupt. But Solaris was really the company providing most of the server at the time. PCs were not reliable enough to work in a heavy environment, and Linux was getting okay, but the hardware quality was definitely not there. And so Solaris and Sun was actually owning the market. And with Solaris Zone, we could actually create parallel zones, and you could easily do up to 10,000 zones on a single server, which was really very, very practical to create hosting a web server, which by definition want to be somehow independent, especially you want to provide independent administrations to the user of this web server, so you can actually sell them for a low price. The namespaces in Linux had an initial release roughly at the same time in 2002, but it really started to be competitive by 2006. Before that, it was very, very restricted. And people started to really hear about it and understand the power of it when the container have shown up. And there were a few containers that were used by specialists, especially virtual zone, then LXC. But it's really when Docker came in that the concept of container really blew up in the market, and that when the use of namespaces started to be extremely important, and also when we had to add a few features on the namespaces. So what's the concept? The idea of namespaces is that we are going to create parallel worlds, and we share the same kernel. So more or less the idea is that you execute the same kernel, but you tag every incoming call in that kernel with a specific marker to say, hey, this is coming from my namespace, 2, and this is coming from my namespace 3. And so even if I call the same API and I call the same file, it's actually different. So that's the very basic principle. It's concept for those of you who are using languages which support namespaces, like for example C++ or Python. You know about that. You can create isolation in your language in such a way that you can reuse the same name for functions and from variable. So if you have multiple developers working in parallel, they don't have to know what the other one is doing to avoid conflicts. The same in XML description or in JSON descriptions as well. In languages it's been used before. It just allowed to scale up the numbers of developers. It has exactly the same principle. More or less, we execute the same kernel, but we just tag the information and we make them independent. And so it's a kernel which is actually keeping these worlds isolated. So everything relies on the kernel. And it creates subsystems which are like layers on a drawing. And those layers can be more or less transparent. You decide how opaque they want to be, especially in Linux, because your namespaces are very, very flexible. As I've said, it's been used to create container services. That is a way that people use namespaces for most of the people, except if you are developing very specific services, most likely you will never use them in another way. In one way, it's equivalent to virtualization. A lot of people call that light virtualization. From a cybersecurity point of view, it's very, very different. And I want to insist on that. Virtualization, you really run a full OS and you maintain it like a full OS. You just happen to share the same hardware. Containers are different. If you do that, you will fail. You can do that, but it's not the way to use them. It's very dangerous if you start to use them like that. The main interest of containers is that they are so small and so light that they can start and stop almost as quickly as an application starts and stops, which means that you can actually dedicate a container for each application, and that's where the power of the container comes. We will see the detail of container in a following lesson, but I wanted you to immediately put in your head that virtualization and container are, on the technological point of view, fairly similar, but in the use, it is very different. And if you use them in the same way, you have something wrong somewhere. Good thing with namespace is that fundamentally they don't provide any overhead on the operating system. It's just negligible. Because it's simply a marker which is saying, okay, this call is coming from the layer number 5, and that's it. That's the only difference. So a little bit more RAM, and that's it. But from a CPU point of view, you don't even notice it. So for what do we have namespaces? Actually, for a lot of things. And here I have them in alphabetical order, and after that I will put them in more logical order, and especially the way they have been invented, because we start by the most obvious to go to the least obvious. But here let's make a quick list. So, and this is a list as today, and actually it's not even complete, and the list is growing. I already said that at the beginning. So the first one we have on this list is C groups. We have already talked about C group. We know that it's a capability to control and restrict access to resources, various resources, which can be CPU, RAM, block I/O, devices, network. And here you're going to be able to create different C groups. Well, what's the advantage, we could think that, because C group are very flexible. You can make a tree, you can make as many trees as you want of C group. We have seen that in previous lesson. So, why would you need to get a namespace? Fundamentally, the interest in having C group namespace is that it avoids that two children from parents which have created these namespaces have the capability to see what the other one is doing and have the capability to actually put features in the other C group. So that's mostly the interest of creating the namespaces. Is really a security feature. It stops to have access to data which could be used fundamentally for hacking. So it's very much a security feature related to data gathering mostly and intelligence. IPC, that is more obvious because typically it will allow to create, for example, sockets which have the same name. So you don't have to know the name of the socket, and there will be no conflict. Same for queues and requests in general. So it's quite a practical system which avoid conflict, increase flexibility. From a security point of view, if you use a mandatory access control, you cannot access to the other one either. So you can do the security side with mandatory access control as well. It's just a bit more complex because then you have to synchronize the work between both tasks. So especially when you create complex system and you want to scale up large development teams, it becomes very powerful. Network, very similar to IPC in the use. It's probably scaling up facilities. Mount point, this is really a security feature. It's one of the most complex ones to use, to be honest. I'll come back to it. But what it does allow, it probably allowed to hide some part of the file system, and it avoids to share some part of the file system. For example, you can have multiple /temp. Now, we know that distribution do that as well, and they create a /temp for every user. But it's fundamentally very complex to manage and quickly can get wrong because you have some default application that will not look at the variable $temp to find where is the temp directory, and then the system will stop to work because they are misbehaving and they want to write on /tmp in hard because by tradition /tmp has been the shared temp between all users for the last 40 years. And many applications are just assuming that, and it's hardwired in the code. Here you're going to be able to change that. You're going to be able to move them, same for home. So it gives you capability to do things in such a way that you will have a flexibility that does not require the application to collaborate. You're going to be able to change that tree and disk organization without having any request on the application. PID. The interest of PID is mostly that obviously it avoids to have the children being able to gather information on the other children, so it's an isolation, but it also allows to have as many PID1 as we want, and as you should know from the lesson number 1 around the boot, that the init, which is the first task triggered when you boot after booting the kernel, always has a PID1. So if you want to run an init, you have to get capability to get multiple PID1. Users, once again, they provide at the same time, a little bit like network and IPC, capability to isolate and to scale up, and a little bit in equivalent of PID1, it's also allowed to have multiple root. You know that root has a UID 0, and you only have one in the system, but with that method you can have multiple root. Obviously you will be root only in your small domain, but that allow you to do things in your domain without getting privileges in the other domain. And hostname and this domain name, this is really interesting when you want to do web hosting. It's a very practical feature for that, and also to stop to gather information in one way. So let's look at the network namespace. It's one of the useful ones, very practical. It allows you to create virtual Ethernet interfaces associated with the namespace only. And the trick is that a virtual network will create actually a pipe. It's like a cable, it's like an Ethernet cable. So you have one socket which is ending in the new namespace, and we have another socket ending at the parent namespace. And here socket not in the sense of socket like we know in System 5 or Unix socket, but in the sense of a cable, where you have two ends and you have two plugs, and you plug them in the socket, and you have the communication going. So the parent will see one side, and the new created child will see the other side. And any data you put in one side arrives with the other one. And very logically, the parent will create a software bridge, and there is a utility in Linux to do that. And that bridge will behave like a switch. That's what we can see in the graphic. It's called routing process. To be honest, it's a bridging process. And you're going to be able to have your namespace talking to the host, to the parent, as well as to the other child, if your firewall allows it, because on the bridge you can put a firewall if you want and define everything you want. You could also go in layer 3 routing if you want, by creating multiple bridges. You're absolutely allowed to do that. So the network namespace is a very important point to allow isolations of communication. User and group namespace. As I've said, the number one use is to clone the root user. So you can have as many root as you want, with the specificity that they are all identical but different. What does it mean by that? It means that if you have a namespace A and a namespace B, the root in the host, the parent, the root in the namespace A and the root in the namespace B are all going to be different. In the parent, it will really have the UID 0 all the time. But in the child, it will not have the UID 0 when it's in view from the parent. It will be mapped as an ordinary user. While in the namespace, it will be viewed as 0, which means that you will be allowed to execute privileged tasks inside your namespace. So it's a very important point. For example, you will be able to change the ownership of a file in your domain with your privilege 0, but not outside. So there is a mapping which is done, and that mapping is actually tracked by the system and can be looked to proc_file. So important point is that there is no cross visibility between child namespaces. So if you have two children, they have no visibility of the user and the group which have been created on the other namespace. Obviously the parent sees everyone. Process ID, in a very similar way to the user namespace. It's fundamentally doing a cloning with a cloning especially of the PID1. Why the PID1 is so special is because if you want to initialize a kernel, like if you were booting it but in a new namespace, which is what you're going to do, you're going to rerun the initialization. The first task that will be called is going to be created with a PID0. As you have seen in the lesson 1 around the boot, by default that task is init, and you can change it through the command line of the kernel, but by default it's init. And this init will be created with PID1. So if you want to be able to create multiple instances of your kernel, which is what we want to do, you're going to have to get multiple PID1. Obviously the parent, the host of the system, will have only one PID1, and so the child namespaces PID1 will actually be mapped on ordinary PID inside the parent, because we still have only one kernel, so there is only one thing running. Remember, it's a layer system, so it's an illusion of being a PID1. And like for the group and for the user ID, there is no visibility between children's between namespaces. The mom namespace is a little bit more complex. Reason is that when it was originally created, it looked to be a good idea, and the way it was done was creating a huge amount of security concern, and so it had to be reworked a lot in order to still allow it to be usable, but to not create fundamental security backdoor. So the base idea remains the same. It's a cloning again. We're going to clone the mon point, and but we're going to say this is going to be the origin. So we're going to have multiple slash or root file system, one per namespace. And the DAC are going to be mapped with the local UID, GID from the child namespace. So until there, it looks like a traditional namespace. Then the trick is that the virtual drive is actually going to be mapped on a directory of the hosting namespace, and that means that actually that part is going to be visible, obviously, from the host. But you have different way of requesting that mount. It can be requested by the child. So once you are executing in your new namespace, you can say, okay, I want to, in my new namespace, I want to request a mount. Like you can do as a user, it can actually be imposed by the parent at the creation of the namespace. In a very similar manner from a CH root, it's created for you and you have to use it. And then you have multiple modes which are available. It can be shared, it can be private, it can be slave. Slave is when it's imposed to you. It can be unbindable, which means you are not allowed to actually mount on it. And then you have propagation rules which are not obvious. So my advice, if you have to create a bespoke mount namespace, read the documentation at least 3 times and do some tests. It's a complex namespace to use, not overly complex, but a little bit more than the other one, and especially if you do things by selecting the wrong mode or requesting in the wrong way, you can sometimes believe that you have what you want and realize that from a security point of view it can be undone. It can be changed, it can be mounted somewhere else, and so you can get it wrong quite quickly. C group and MAC namespaces. So MAC is mandatory access control, you all remember that from previous lesson. So the C group, very similar. You can create as many C group as you want. You can create multiple tree, and as I said when I was looking at the general list, the main value is to stop to share cross data, especially critical data like path of the executable, the name of the framework you are using, which otherwise could be seen. If you have, for example, put a limitation in your CPU bandwidth, on your web server, and it happens that it points to a PID which is running Apache. A malicious software will be knowing that you're running Apache, which is already an information which can help to try to find out what are the current known zero-day attack, or recently closed zero-day attack on the Apache, because we all know that most of web servers are quite late to be upgraded and updated with security patches. So that's really the big advantage of this C group. The mandatory access control namespace is more tricky. First, it's very recent. And if you are using namespaces, it's actually mandatory. And originally, when you were spawning a namespace, you only had the original mandatory access control, because you cannot change the label. Remember what I said in a previous lesson, one of the main advantages of mandatory access control is actually when something is fixed, it's fixed. You cannot change it. It's immutable. And here we wanted to be able to do it. So there were discussions which happened about 2 years ago, if I remember quite well, when it was going on. It was a time of when I was working on Tizen, where we had actually the problem. It requires a mode which is a little bit interesting on directory, which is a poly instantiation. So you have more or less to create multiple version of a directory, because they have to get different labels and not see the other one. So that's something that was missing, which has been added. It is available for SE Linux, which is mandatory access control that we have seen in a previous lesson. There is prototype running for SMAC. I did had access to them at the time Samsung was writing them. They wanted to do that for using LXC on Tizen. To be honest, I have not checked how well it works, and we are not using it in automotive grade Linux, which is a project where I'm running today, where we use also SMAC, but we don't have that problem yet, so we didn't put our nose in it. But I know it kind of works, and if it works for SE Linux, it most likely work for SMAC, because the labeling issue is exactly the same in both security framework. AppArmor, to be honest, I don't know. I know you have to use policy stacking, and it's normally possible in AppArmor, because AppArmor does not require to have anything on the file system, so in that way it's advantageous. But I didn't check, and I didn't find much information on it. So if you have to use mandatory access control in something which is depending on namespaces, be very careful. And as I've said, containers are actually using namespaces, so if you need to activate mandatory access control on a container, which might not be a good idea, you will likely need that, so be careful with it. And you have other namespaces, and as I've said, the list is still growing, because with the success of containers, especially Dockers, which is used in the cloud, in immense quantity, they have realized that we had some limitations, or we had some stuff which were creating security weaknesses, and they have been patched one by one. One which has been added recently is systemd, so you can have multiple systemd, which allow to boot fundamentally a system in a system. We talk about POSIX queues, but you can also have some credential, different host name. Almost you can create a virtual machine. Now, it's, as I've said, if you are running container, you should not go toward virtual machine model, but if you are on the opposite side needing to run a virtual machine on a small system which cannot manage a real full VM, you have the capability of doing it. Remember, you are sharing the same kernel. And actually, a few shared lib as well, quite a few. Okay, in the read-only, but you still share them. So that means that if you are running, for example, what you believe is to be an Ubuntu, you may have a kernel and a level of library which were never designed for Ubuntu. You should not have too much problem, but you can find some side effect once in a while. So, especially for people trying to get close to virtualization, remember that namespaces is not virtualization, and so if you go from a host A to a host B and they have different operating system underlying, you are a good candidate to get big surprises. The extreme system in the concept of namespace is what Microsoft did introduce very recently in Windows 10. It's still marked as a beta, as I am speaking today, so in December 2017. But you have the capability to run Ubuntu and OpenSUSE, and those are the two which have actually been supported, on Windows 10. So Windows 10 fundamentally provide a Linux API and behave like a namespace. And underlining is not a Linux kernel, but it is a Microsoft kernel. It works surprisingly well when you think about the complexity of what has been done. I have tried to use it for a specific project running creation of images for embedded Linux devices with the Yocto project, and that failed miserably, I have to say. But Yocto is using extensively the hard link on the file system, and Microsoft emulation system never thought that it would be used that widely, so it just crashes after a certain time. But we can see that it's most likely going to work soon, and for other basic stuff and even reasonably complex software, I've been able to run it surprisingly well. So if you are curious, just take a Windows 10 machine and activate the Linux for system. First you will have a bash, which is very, very handy. They'll have a real bash running on a window if you have to run Windows. But you can also have a lot of things running quite well. By default, they create in the namespace a light virtualization, which happens to be Ubuntu. If you want to install OpenSUSE, you have some manual work to do. But the Ubuntu is by default, so it's quite easy to play with it and to test it. Now, we've seen what namespace can do, so it really allows to create parallel worlds that you are going to use either for creating independence and scalability when you have big teams and complex deployment production, but also for isolation, which is a way of implementing security. Isolation is a critical part of security, because as we have already said several times, the question is not to know if your system is going to be hacked one day, but the question is to know when it will be hacked. And once malicious code is in your system, obviously you want to make as difficult as possible to move from one part of the system to the other one, hoping that your other processes you will have put in place will give you time to detect that actually you have been infected, to understand what's going on, and to shut down the attackant before it has capability to do any nasty things. So in that point, namespaces are a very, very useful tool, because, as I've said, they have zero overhead or negligible overhead. You can just ignore it completely. So it's not a problem to run 10,000 namespaces to isolate, even very simple tasks. As an example, for those of you who are using Gmail, every time that actually you connect to Gmail and every time you actually do something on Gmail, you spawn a namespace, which is a very light container that Google has created. And that task is just doing what you want to do, reading your email, writing one, sending one. And as soon as it's finished, it's just disconnected. Even if you are still having your page which is displayed in front of you, it's only when you're going requesting to do something that actually Google is going to spawn code in a new namespace to do what you want to do. So it can be very, very light. Now, as I've said, likely using container is going to be the way people will use it. I've put 3 names. I would say that today 2 are mostly well known. The other one is still practical, Docker, which is the star of the cloud, but which is very heavy and which does a lot of things that sometimes you don't want. LXC, which is a light container in embedded, that's always the one we look at. But if you just want to scale up system and you don't want to do automatic deployment and having capability to relocate container from A to B, if only you're not doing a cloud, you're either doing stuff for security reason or for scaling up reason, LXC is a very good software to look at because it's significantly lighter than Docker. It's also simpler, which means that from a security point of view, it's easier to understand what it does and so to secure it. And Virtual Zone is another one, which is quite handy when you want to do light things. It's very light ones. It's even lighter than actually LXC in one way. It's really when you want to scale up and make securization, but you have less tool. So if you go down, Docker is the top, everything is done for you, but you don't really know what it does. LXC, it's a little bit more manual and the restrictions start to be very visible. Virtual Zone, you probably, configure the stuff by yourself and it does only what you want. All of those are actually creating light virtualization. Rather than just doing very basic namespaces. Manually, you can actually take the easy route, which is use systemd. Systemd has a capability to impose some namespaces in units before actually activating them. And the last one is by hand, so when you write your code, you can decide to spawn the stuff, so which is a very valid option depending what type of business you're doing. Now, as I've said always when we talk about this type of concept, which are quickly becoming so complex that people don't understand what's going on, try and check the side effect of everything you're doing. There is no free lunch, as they say in English, and it means that yes, it's a great flexibility, but you still have some side effect. You also still have some security weaknesses, which are in that case significantly more hidden. And the fact that you hide a backdoor is not going to make the system more secure. It's just going to make it more difficult for you to find out when you have been hacked, because professional hackers knows about those backdoors. So the namespaces are definitely less secure than they look. They look, when you do a first look at it, you say, oh, that's great, everything is isolated, different domain. And in reality, you have some capability to do some jump from one to another one, either because you have some defect in the concept of the kernel, or some bugs, zero-day attack, or some limitation. As I've said, for example, the non-namespace has evolved recently quite a lot, because the original implementation of it was actually quite weak from a security point of view. It's far better today, but still can be better. Check attention to details. That's a very, very important thing to remember. Now, there are plenty of examples on the net. So you can look at example of mount namespace. That's a very practical one. Mount namespace are very, very handy to avoid a lot of conflict, especially mounting /temp. So it's very basic stuff, but it's very, very useful, or to stop, to restrict access to a few things, or to have different versions running for different users, because for migration or for restriction legally, you may want to create that without having to change your application. That's the main interest of that. You can look as well on the network, and especially with that you will need to understand extremely well how the bridge works. Because namespaces are going to talk together, if they go for full isolation, the only thing they have to talk is the network, which is happening on container. So you really must understand the way that the network bridge is done inside Linux, and how the software bridge is creating, and what constraint it has, how you can troubleshoot it, how you can firewall a few things. You really need to look at that. And finally, I did put a link on the light container LXC, because I believe that, you know, if you need to use namespaces to isolate things without doing full container, you're either going to go through systemd or you're going to go through LXC. That's the two most likely routes that you're going to face. So I would advise you to look at it. Now remember that your future job is going to be cybersecurity. So don't expect people will use it in a normal way. When they're going to hack you, they're going to try to find sideways. So you need to understand clearly the concept so you can detect what's happening abnormally. We arrive at the end of this lesson. As I've said, it's a complex concept. It looks simple, but you're going to see when you try to do your workshop that it is quickly becoming complex, and you can get it wrong as easy as you can get it right. But it's worth to invest. Namespaces provide a very powerful cross-application isolation, as well as a capability to scale big teams and big deployment, which is important, or on long term. Mastering the side effects is not easy. It's not easy because it's complex, and secondly because it's still evolving. It's definitely moving. Container and systemd are a great helper to implement it. So, as I've said, most of you likely will never do it in another way. The danger with container in particular is to lose the control of what is running on the system. And on the next lesson we will talk about virtual machine and container, and especially Docker is dangerously simple to use, and it's very easy to do very wrong thing, especially from a security point of view. And I will repeat it next week when we talk together again, but if you use Docker and even LXC as mini virtual machine, likely you're doing something wrong. And you should think about it. It has some cases where it makes sense, where you want to run a virtual machine but you don't have enough power, so you know you accept the security risk and the side effect of running virtual machines inside containers. But that should be the exception. Okay. When you run container, you should not run as a virtual machine. You would rather run it as an application, isolated, running only its own container for only that application, because they are so fast to start that it's not worth to not do it that way, and then it becomes manageable. As I've said, overhead is negligible, so don't be worried if for security reason you have to isolate 10,000 requests coming, you know, in 5 seconds. It's very acceptable to say that you're going to do a new namespace for each of them. There is no reason not to do it like that. Okay, performance is not the issue. If it doesn't work with namespaces, it will not work natively. You know, the difference will be certainly less than 2%. So don't bother with that. It's a very powerful tool to limit movement of malicious code in an infected system. It's not completely stopping it, but it's definitely slowing it seriously. And if you are just attacked by people who want a little bit of your money, most likely they will give up, because hacking system is a business in itself. So if it takes too much investment to be able to hack your system which is under your protection, they will try another one, which is easier, because the return, if you have to invest too much, is not good. And on top of that, if a system, when they detect that the system is properly protected, They say that's dangerous. They could be tracked, as it could be detected, and they lose all their investment into getting in your system. So quite often it will just stop them. Obviously, if you're running very critical infrastructure and you can be attacked by a serious professional because there is a lot of money to get out of hacking the system, or you are running on domain which are at national level of interest, and you can be attacked by state-sponsored teams. That's another world. As I've said, those people will always try to invest, and the investment is not a problem. Then the level of protection has to be sold differently. But fortunately, we're not going to be all in that situation. Like last time, a few things that I believe you may want to look on the net. There are good tutorial. I found one from LWNet, which is actually a good place in general. The format is always a little bit plain and boring, but in general the content is very good. And you can see it's not new. This is from 2013. But to be honest, the concept remain the same and unchanged, and beside of a few features which have been added, it's very relevant. We talk about systemd. Systemd is very complex. It's almost a system by itself. But you can look at NSpawn, which allow to create container on the fly. So it's between doing it by hand or using something like LXC. But it's very easy because you can actually put your features. You create your unit. For example, if you want to start an Apache web server, you can decide, what you're going to isolate, and create your pseudo image. That's everything you want to change, more or less, can be changed. It's pretty recent, so you need to have a recent systemd running to have it. I just make another small aparté. It's not really namespace, it's seccomp, but seccomp is always something we talk. They say it's very difficult to use, but in Red Hat they have put with seccomp something which is not really related to seccomp, which are the Linux capability. We didn't talk about it in any lesson. That's something you will have to do it by yourself. But the Linux capability is a very interesting system. It's probably originally root, the UID0 had all privileges. In a modern version of Linux, this capability from root can be actually removed. So you have the capability to say that you want to lose capability. And it's especially very interesting when you're going to create namespaces, for example. You can do that. But, for example, there's things that we know traditional that root can do, like, for example, changing the owner. You can decide that the root cannot do that. Overriding the DAC, discretionary access control. If you cannot override it, the discretionary access control becomes significantly more powerful. And so on. So you have capability to, for example, not send a raw packet on a network, which is a very important point, because it means that malicious code then cannot create its own packet. Otherwise, you can't do it. You can send raw data, you can fake an ECMP, you can make an invalid packet. If you cannot send raw, you have to go through the stack, and the stack is not going to send invalid packet for you. Type things like that. So have a look at it. Once again, it's something which is also pretty dynamic. Quite recently, there were more capability, granularity that was added. It's something which is worth to know. Once again, capability can be activated through systemd, so it's quite easy to activate them. So have a look at capability. It's a very nice and useful tool. And before leaving you, could not resist to the pleasure to invite you to do some homework. So first, let's do things by container. Install LXC, not Docker, install LXC. So you will have a little bit less control. Create a container for Apache and use the IP table that we have seen in the previous lesson, or NFC table, or your firewall if you have activated your firewall with firewall ID to route inbound traffic coming into your host to your newly created container on the port 80, so any incoming 80 traffic goes to the right place. Then by hand, I would like you to find a way to remount for a given shell a new point of /etc, which would be an empty directory, in such a way that de facto /etc become a fake version, so if any changes is done in it, it doesn't matter. We can do this type of things with overlay FS as well, which is something you may want to look for your curiosity, which allow to work with read-only partition, which is quite interesting, because especially from a security point of view, then you can always come back to the factory setting. It's quite often used in embedded devices. And also look at /gmp and try to remount a /gmp, which is different for a namespace, pointing to a clean mount point, which is on a RAMFS. So when you will delete a namespace, /gmp which was used will go away. And have a look at what happened when you create child and parents, and look at the perspectives that you have from UEID and process ID from the child as well as from the parents. Look at the same process and you will see that actually the PID and the UEID are changing. So you need to understand that, and you can find the correspondence through some pseudo file system in /proc. There was a very good Linux magazine in France, which is actually only available in French, but some of you speak French, so it can be quite handy, which was special on namespaces. I believe it was published in 2015. It could be 14. I could not find it on their website, so it may have not been digitalized, but if you look in your library at the university, likely you will find it. And they had very good simple workshop and clear explanation. But otherwise, check a little bit on the internet and you will find some workshop to play with that. Once again, as I've said, you will use it likely through systemd or through LXC, so except if you are in the development world, that should be enough for your usage. The mapping is very important when you come to troubleshooting, so you have to be very careful of that. Find out how you are capable to follow the mapping from the host to understand what's happening, because you may not have access to the namespace, especially when it's container. With this, I wish you to have a good time with the homework and a lot of fun with namespaces, and talk to you next time about virtual machine and containers. Have a nice day. Bye-bye.